Okay, so for the next video here, I'm actually solving one from the homework problem. This is number 11, which I think it's actually a really kind of cool problem. So everything is generalized, right? There's no numbers here. Some are variables, some are constants, so we have to kind of pay attention. So it says find the volume of the largest right cylinder that can be inscribed in a sphere of radius r. So this r right there, even though it's an unknown, it's constant. Where the little r and this h, which is the height, those are variables. Like we're trying to pick and choose, well, which ones will give us the biggest, will give us the biggest volume of this cylinder. Now, in case you forgot, volume of a cylinder is area of the base, which is pi r squared times the height. Okay, and so, it's something like that, even though I think you should know that, the AP exam does a good job of giving you those geometric formulas. Okay, now, but the problem here is that, or not the problem, but the thing I should be cautious of is that r squared and h are two different variables. That means if I do the derivative, I'd have to worry about a product rule. But I can actually avoid the product rule if I realize that there's actually a relationship between those two values. So if I draw this here, I have a right triangle. Well, if the whole thing was h, this is actually h over 2. And this r is the same as the hypotenuse of this triangle r there. And so I have the Pythagorean theorem. I have r squared plus h over 2 squared. So r squared plus h over 2 squared equals r squared. And the reason I like that is because I have a r squared here that I could simply solve for. So I could say r squared equals capital R squared minus 1/4 h squared, right? Because 1/2 squared would be 1/4. So I'm going to substitute this into our volume formula. So volume equals pi capital R squared minus 1/4 h squared times h. And let's distribute this h in the pi. So volume equals pi r squared h minus 1/4 pi h cubed. Okay. Now, again, let's remind ourselves, what's the variable here? The variable is h. So I have a linear term. Don't be distracted by this r squared. That's just constant. R squared is as a value is a constant. And I have h cubed. So this is a cubic function. So this is very predictable and smooth. And my point being that when I take its derivative to set equal to 0, I have no values I need to worry about for undefined derivatives, just 0 derivatives. So volume equals, if that's an exponent of 1, it just comes down. So it's still pi r squared. H is gone. Minus 3/4 pi h squared. We set it equal to 0, and let's solve. So that's pi r squared minus 3/4 pi h squared. We're solving for h squared, so let's add it over. So 3/4 pi h squared equals pi r squared. We're trying to get h squared by itself. So we're going to, work from last year. So we're going to get h squared by itself. So we're going to divide by 3/4 pi, cancels that. Now the pi's cancel, and the 4/3 kind of flips over, right? So h squared is equal to 4/3 r squared. Square both sides. So technically we get a plus or minus 2 over root 3 times r. But since r, since we're talking about a positive height here and a positive radius, we pick the positive value, the positive root. So h is equal to 2 over root 3 times r. That'll guarantee the biggest cylinder. Now, it doesn't answer the question though, right? Because the question says find the largest volume. So I actually need to go back and substitute that in. So right here at that moment, I have volume in terms of height. So I'm just going to go ahead and simplify that and say, okay, so my volume, so now the smartboard's on its own. Okay, there we go. Pen. Volume is equal to, and we said there, almost there, pi r squared times the height, which you said was 2 over root 3 r, minus 1/4 pi h cubed. So that quantity, 2 over root 3 r cubed. So let's see, r and r squared is r cubed. So it's kind of an awkward coefficient, but it's 2 pi over root 3, and that's r cubed, right? R squared, r cubed. Minus, let's see, I have 2 cubed is 8, and I have 8 over 4, so that would just be a 2. So I have 2 pi, right? 1/4 pi, and right, 2 cubed is 8. And then root 3 cubed would be 3 root 3. And we have our r cubed. Now, if I multiply this function, this fraction, by 3 over 3, I'll get a common denominator. So that's what I'm going to do. I'm just going to take that and multiply by 3 over 3, so that I can get a common denominator. So now I have, go here. I've got 6 pi over 3 root 3 r cubed minus 2 pi over 3 root 3 r cubed. Same denominator, although it's awkward. 6 pi minus 2 pi would be 4 pi over 3 root 3 r cubed. Now, if that bothers you, rationalize it. Root 3 over root 3. So you could say it's 4 root 3 pi over 9 times r cubed. So once you know how big your radius is of your sphere, this tells you how big that volume is. So I like that problem. It's a great problem. And again, you start thinking about like real world context, right? So like you start trying to, maybe you've got a cylindrical tank or storage space, or you're filling up a certain chemical or material, and you're trying to see, well, based on this size, what's the biggest volume I can have? So there's other ones that deal with surface area, and what's the smallest surface area to enclose something? I think about like in packaging, and that'll minimize the cost, overall for your company. So okay, so the next video, or at least the one more video, if not maybe two, we'll deal with using our calculator. So for the next one, make sure you have your calculator ready.